average. What's the average speed? This is the kind of thing that would be the typical warm-up question on a test.
What does the bottom thing say?
What is the,
Yeah, I
Okay.
can read that.
what is the average speed?
Okay. What about the one above that? What does the?
What distance does the object travel?
Wait, the last one's what?
What is the average speed? Using a V without the vector symbol over it to indicate speed. This is AV for average. So we put the bar there, but that might look like a vector symbol. Right. Any other translations? Or the same translations?
We get the equations on the test, right?
Yes.
Okay.
And if I forget a question, just ask, or forget an equation, just ask and I can put it up on the board. If you want to mess with people's heads, ask for an equation that you know is not needed. And then I'll put it up on the board and have people wonder why they need to use it, what they forget. The equations I will give you, if you look at the summary section of each chapter, I will give you those equations. There is an exception in the momentum chapter where they give an equation that I will not give, because it prevents sloppy thinking.
The last one was average velocity or
Speed. V for speed. Not vendetta. Or for those of you kids, Violin.
When is our first test? In September?
Yeah, it won't be this week, so yes, it'd have to be in September. So we'll fill it out. We'll get Master Set 2 down on there today, and
So that's gonna be for us?
Yes.
So we have everything on, okay.
all right, any other questions about the problem before we begin solving? All right, I'm recommending that, since you're trying to find final displacement, well, regardless of what we're doing, let's set up the 5 quantities, figure out what we know to start with. So I have displacement, initial velocity, final velocity, acceleration, and time, which is the big 5. What is given in the problem?
Initial velocity,
Which is,
-15 meters per second,
okay,
and the acceleration plus positive 7 meters per second squared, and time, which is 11 seconds.
all right. We know 3 things, we should be able to find the other 2. And so, what are we asked to find in the first question? All right, which equation do we use?
Initial velocity plus final velocity divided by 2 times time.
Wait, which one did you just say?
Oh, we're using those. Oh, the initial, we're finding displacement,
We're finding displacement.
so the bottom equation,
What's wrong with using the bottom one?
because you need the final velocity,
Yes.
but couldn't you find the final velocity first?
Yeah, you could. That is definitely we can do that first. We don't have to answer the first question first. Margaret, then Robin, then
I would
Laura.
use the initial velocity times time plus
Okay, the third equation.
the third one.
Yes, okay, that would be to find it directly. Abigail's suggestion also works. There are times in which it is convenient to find something else first and then use that. Because in the at what time is the displacement such and such, We'll end up using a quadratic formula for that. If we don't, if you don't like using the quadratic formula, you have to find something else first and then use that. But, okay, Robin, you had a question?
No, I was answering.
Okay, Lord,
That was the same thing I was gonna say.
okay, and any other questions? All right, so using the third one, I have delta S. It is recommended that you start out writing the equation. If you get if you get much more comfortable with it, you can skip some steps. But it's a lot easier to follow your work if I see your equation first, and then plug and chug. So we have negative 15 times 11 plus 1/2, 7 times 11 squared. It becomes a calculator exercise.
Do you want us to say?
It's on around 250. What is it?
258.5.
258.5? Thank you.
So
It's
it's,
generous of you to let someone else share some of the board. Robin?
so it's okay if we don't put the units of measure on the equation itself, like negative 15 meters times 11 seconds?
Yeah, it's perfectly fine.
Okay.
And it gets really cluttered for when most people do that. I've seen some people do it, there's no problem in doing that, but I know that I'm starting out in what I refer to as nice units. I'm dealing with meters and seconds. I know that my displacement will be meters in the end, so I don't have to keep track.
And also, you don't need to do sig figs anymore. We don't need to do sig figs in here because if it was sig figs, it was supposed to be 300 or something.
If it were sig figs, it would, yes, be 300 because of that 7 there.
But in the test, we won't be required to use sig figs.
Sig figs only for that very first lab.
All right.
Once you've handed that in, you don't have to worry yourself about it until you get into chemistry or one of those other subjects that care about that thing. If you do want to care about significant figures, and you put an answer of 300 meters down, I'd look at that 300 meters and I go, what? And then, if you don't show your work, I'm probably not gonna give you any credit. So, if you're gonna do sig figs and do that kind of rounding, just show your work. All right, so number 1, done. There's the answer, and let's go ahead and make it official over here. $258.5 meters. All right. What is the final velocity? I now know this. 258 meters.
We could just use the first equation.
Okay. So VF equals VI plus AT. And so that's equal to negative 15 plus 7 times 11, which is 62. Is that right?
Yes.
Yeah.
Which is about 130 miles an hour.
Are you able to use the second equation?
Yes, you could have used the second equation also.
So that's what I did, but I didn't get that same answer.
But you get it?
I got 58.26.
All
I
right.
could have got it wrong.
So if we did the first one, oh, sorry, that second equation, we have VF squared is equal to 15 squared plus 2 times 7 times 250.
8.5. Yeah,
And then you ended up with VF.
58.26. And that's what when I squared it. I mean, I square rooted it. So I don't know.
Now, if you come out with 61.5 or something like that, I would say, oh, it's a rounding thing, but
Yeah, I can do it again on my calculator.
I, got that answer because I did the final velocity first, and I plugged it into that last equation, and it gave me a different displacement.
So it's sounding like this number here might be off.
No, it's. Oh, wait, I got 62.
Okay, you got 62 that time, all right. But you did not get
Right, so I
258.5?
put the 62 into the VI plus V final over 2
Ah.
times time, right?
Yeah,
It didn't give me, it gave me 176.
Wait, which one did you do?
I did that last equation and I put 62 in for final velocity.
so you got negative 15
Right.
plus 62 divided by 2 times 11. That's what you did?
Yes. I'll do it.
I got the same 258.5.
It gave me 170, how did you put it in? Plus
Plus negative 15 plus 62, literally divide by 2, then multiply by 11.
Did you do it all in one,
Okay.
did you forget parentheses?
No, I put parentheses, but I did it in one equation, it still gave me that 176. Is it because you did the negative 15 plus plus 62 divided by 2 and then times 11?
Parentheses,
Yeah.
negative 15 plus 62 times 11 divided by 2.
That's not what I
Yeah,
did.
that's not right.
But I got the right
Divide.
answer.
Okay, all right, so, or
Divide then multiply.
divided by 2 times
Yeah.
11.
Oh,
That,
no, so I got, okay. I don't know, I guess I just put the wrong parentheses before, I divided by 2, divided it by 2.
all right.
So that gets the right answer.
When the physics was in Ardmore, the main room for physics over there, as you face from the board, there, the really bizarre results came from that corner right there. And as in, no explanation for why things did what they did. It's possible that the poltergeists are now invading that corner and just messing with your calculator.
Probably.
Okay.
Oh, the one that I got in the beginning? Yeah, so I did it twice, and if you don't do if you don't put it all at once in your calculator, you'll get the 58.2.
So you want to.
But if you, I had to put it all, and then I got the right answer.
You see what I'm saying? All of those numbers are multiplied by each other, so it's trying to.
And the moral of this one, of this is,
Yes.
show your work.
The moral is, remember Pentecost.
Parentheses after square. Plus. And then
All right.
parentheses.
Average velocity,
Would you do displacement over time?
you could. So 258.8 divided by 11, or,
And then.
so average velocity, if we know the displacement, so 258.5 meters, so it's delta x over delta t, over 11 seconds, you would end up with
23.5.
the whole thing.
Meter per second.
How else could you have done it?
Average, like the average of the two velocities.
Yes. So add them together, divide by 2 would also work.
Wait, how do we get 258.8 for the displacement if we're using 258.5?
Wait, sorry,
How do we get the answer 258.8 meters, but we're using 258.5?
isn't it? I have 258,
It's supposed to be 0.5. I guess you wrote it wrong.
I have it, oh, right there. Sorry about that. And for the international fans playing a drinking game, that's. Questions to hear? Robin?
So for average velocity, never mind, I did it wrong.
Okay. Glad I could help.
So the notation for average velocity can just be V, average, AVG,
Yeah, or AV.
or just no vector thing.
Well, definitely, well, for average velocity, you could write it, you do need the vector symbol if you're talking about average velocity. And then you could put AV or AVG, or you could put V with a bar over it.
Oh, yeah, okay.
Or for those wanting more sophistication. The expected value, which is the average in some cases. Now, where is the object at negative 50 meters and positive 50 meters? So the problem has changed. We still have the same initial velocity, acceleration, and time, but my displacement is no longer at the end of the 11 seconds. Actually, no, we don't have time anymore. This is gonna change, that's gonna change, and that's gonna change. So we don't know the time, we don't know the final velocity, we don't know displacement anymore. So we're basically gonna set it up again. My displacement is now negative 50 meters, answering the first one. And then my initial velocity, that hasn't changed, that's still negative 15 meters per second. Final velocity, don't know. Acceleration is still 7 meters per second squared, and time is 11 seconds. Up. Time, we don't know. We're trying to find time. Yes?
I don't
Ritika.
know if I'm just confused, but isn't delta S supposed to be change in displacement, or is S the position?
S is position. Did I say change in displacement?
No,
So,
I
okay.
just assumed.
Properly, it is change in position, or the whole thing is displacement. And I quite possibly could have called it change in displacement, but that would have been improper. That's the time you stand up and go, what wolf pack raised you? And then go, I did do a summer at NC State, and that explains it. Go Duke.
Go back.
At least you did say Tar Heels. That would be the worst.
We can hate on UNC together.
Yes. Okay. So what equation should I use to find time?
Third one. I mean, not the
The
third one.
third one.
So you're saying the third one, not the
No,
third
no,
one?
no,
and you're
third
saying-
one on my paper, it's not the same as
Oh,
yours.
what's the third one on your paper?
If you wanna find displacement,
I want to find time. I know displacement.
on yours, it's it's the second one.
The second one. What's VF?
I think it's the third one.
Well, you gotta find
Which
the
one?
first.
Okay, so you want to find VF first and then use the
Yeah.
second equation. And you're saying just go straight up third equation.
Yeah,
Okay,
well, you can't use the third equation, we don't have T.
But you're
that's what
on-
we're trying to find.
Why don't we just
Oh, I
use the
get
last
you.
one as an algebra
But we
equation,
have
fill in
everything
the
else.
negative 50,
Okay, I
the
get it.
VI, and if we find a VF, then divide that by 2 and then use that to find T.
But you're suggesting use this one?
Yeah.
Divided by two.
No, we don't
We
have
don't, we have
VF.
two unknowns.
No, like once we find VF,
Oh, okay.
There's
Yeah,
two.
once we find VF, we have that possibility.
That's what I said.
Can we use the second equation to solve for VF and then use the fourth equation to find?
Thank you, thank you.
Let's find out. Let's do it the two-step process, and then let's do it the one-step process. See if we get the same answers. So to find VF, we don't know time, and if we're gonna find VF first, let's use that second equation. So that finds VF squared is equal to VI squared, let's go ahead and write it out, plus 2A dot delta S. And so this is VF squared is equal to negative 15 squared plus 2 times 7 times negative 50. So first, just tell me what VF squared is. Anyone else got that?
Quick question, why are you not using a vector symbol over, VF squared, VI squared.
When we derived this, we did a dot product, or what's known as a scalar product.
Yeah.
When you do a dot product between two vectors, you get a scalar. So this is actually finding final speed. We have to think through
I remember that.
what the velocity is. Margaret?
I got 21.8.
Is it supposed to be negative?
Negative what?
Oh.
Negative 700 plus
Final
21.8.
Negative 225?
No, like 275 plus negative 700.
That's 225
That's 7,
minus 700.
Yeah.
so it's negative.
It's, you get -475, but then you have to square it.
We can't.
Or square rooted.
Square root it, sorry.
Huh, wow. That's a surprise. What does it mean?
It's imaginary, right?
Pardon?
It's imaginary.
Mathematically, yes, but there is a physical meaning here.
It's in the opposite direction.
Yeah.
You
No.
can't square it with a negative.
A negative velocity?
No.
It never moved.
There is no object, it's a Zen question. All right, the Zen thing, good, in English class, senior year in high school, he read us this, the teacher read us this thing with an ox in it, and he said, what does the ox represent? We all wrote down our answers, and we all entered them in. And at the end, he said, the Zen answer is, what ox? The one you've been mentioning throughout the entire story. Anyway. So we got a negative answer there, and I was expecting that, that's why I was wondering about the 225. I guess someone's just giving me parts. What does the negative answer there mean? Because obviously if I took the square root, well, one thing you don't do is just get rid of the minus sign and keep going. You see the negative sign under the radical, you go, wait a second, it means one of two things. One, there's a mistake somewhere. Or two, whatever the symbol you want to use for two. It's not gonna happen.
It could happen.
Never.
So I thought.
We start out physically what's going on here.